We will be quickly reviewing the OpenAI case study that we were solving using RAGs. The idea is to once again take the OpenAI service documentation. So we will be looking at the OpenAI service documentation, and based on that, we will try to build a kind of a RAG system. Okay, and this is a very real world use case because a lot of organizations are actually focusing on this kind of an approach where you take the technical documentation of some company and you upload the technical documentation and users can query on the basis of that. Okay, so the approach will be very similar to the Tesla DB one that we discussed already in the general RAG discussion. So we'll upload the PDF file, we will create the chunks, we will store those chunks in the vector database as embeddings. And next time anybody can ask questions, like they can ask technical questions about the OpenAI language models. So next time anybody can ask technical questions and we will be able to generate the responses. So this is how the system will be designed right now. Okay, I hope the overall idea is absolutely clear how the RAG system will be designed. And you can see it's quite a big documentation. There are 914 pages. And as I was saying that you can go back and effectively use this in any of the, you can effectively use this in any of the real world applications. Any of the real world applications you can effectively use it on. Okay, so whatever we are discussing right now, you can even go back and use it on any of your personal documents. Let's say you can take some PDF file, you can take your resume, you have a list of resumes in a folder as PDFs, and you can effectively build a RAG system on that. And users can ask questions on the resumes that, hey, find out the top resumes where these skills are there. You can see how the retrieval augmented generation, the RAG-based approach can be extended to any kind of document. Okay, so this is the use case that we are covering. So now we break it up into two parts, as I discussed. So the first part is, and eventually these are the kind of questions we want to be able to solve, right? You can see. So you're a solution architect, and the objective is to be able to solve these questions. So we should be able to, users should be able to ask these kinds of questions, and you should be able to get the answers. So that's the objective. So we again break it up into two sections. First part is we do the vector DB creation. So the first part is we actually create the vector DB. So you can see this is the PDF file. We'll upload the PDF file. And this is the other part. You don't have to use a directory loader. This is what I was mentioning. You can straight away use a PyPDF loader. You need a PyPDF directory loader if you're uploading a folder. That was for the previous use case. But here we can directly upload the file. Even if you want to upload the directory, that's also fine. But the objective is that in the directory there will be multiple files. All the files will be loaded automatically. But you can instead use a PyPDF loader. So if you just have a single PDF file, the PyPDF loader will work. Okay, this is not the only way to read PDFs. There are multiple other libraries in Python you can use, but this is one of the approaches we have used. Okay, so then you chunk the file. We're getting 972 chunks. And next, what we do is we go and create the Chroma DB, the vector DB. Chroma DB is the vector DB that we are using, the open source vector DB that we are using. And the name of the vector DB is AOI underscore DB. So once we do that, the AOI DB will be created in my folder. It is the same approach. I'm not running the code once again. The approach is exactly the same. And then what we do is we go to the other notebook, and this is the part where we do the RAG solution. It's already uploaded in the drive. Everybody can see the solution section uploaded. And what here I'm doing is I'm going and loading the vector DB. The only thing I'm doing is I'm doing the API key, the endpoint URL. All these are the standard stuff that we have done. Make sure you change the model name because we have all used GPT-4 Omni, and we are loading the embedding model. Okay, and we are loading the vector DB. And this is a good way to test it out, right? If you want to test out whether your vector DB is working fine or not, it's always good to load the vector DB. So step one, load the vector DB, and step two, try to see how many chunks are getting created. That is a good idea. That is a good approach to use. Okay, so always try to load the vector DB and see how many chunks are getting retrieved. So you can see the retriever I have defined as it will retrieve total 5 chunks, right? So that is how I have defined the retriever right now. So the retriever should be able to retrieve the top 5 chunks. Okay, so that is how I have instantiated the retriever right now. That's the idea. And you can see that we want to be able to retrieve the top 5 chunks right now. Okay, it's a good idea to check whether your vector DB is loaded successfully or is even created successfully by checking the retriever. Because if your retrieval is flawed, then everything else downstream will be flawed. So if your RAG is giving an incorrect answer, please remember, do not blame the language model. Don't blame GPT-4o because GPT-4o is not giving the answer. The actual answer is retrieved from your vector DB. So if there are any flaws in the RAG application, the first uh, investigation has to be on the vector DB. You should question how the vector DB is created, whether the indexing is correctly done, whether you're saving the data correctly. All those things have to be talked about. And we will discuss that approach as well, advanced retrieval techniques, and what are some other advanced strategies that can be used. Rest of the part is very similar. You create a very detailed system message, which most of you were able to do very nicely, but I have made it a very detailed. You can see, you can use the system message. You can see, I basically copied the problem statement. Whatever problem statement was given, I basically copied that. Okay, this was also one mistake I found some of you doing. Just to summarize the idea, this was a mistake I found that some of you are taking the same system message as Tesla. If you have a wrong system message, even if your retrieval is fine, the LLM will not be able to give the right answer because it is getting confused. So if you say, okay, give me the thing from the annual report, the LLM will get confused, okay, because it doesn't understand what annual reports are from this technical documentation, right? So make sure you have a right system message. So all the components have to work in sync. Even if one component is going wrong, then it will be a problem. Okay, see how we are making it very detailed. What kind of questions the user will ask. There are specific rules that I'm setting. That is the whole idea of a system message, right? System message should have all the different terms and conditions, the guardrails. Okay, although there are separate guardrail models we have, but even in a system message, you can specify some basic guardrails. Guardrails means restrictions or constraints. What things can be done, what things cannot be done, what kind of outputs cannot be generated. So all those are basic restrictions and constraints you can put as part of your system message. Okay, so please be mindful of that, that this has to be very, very detailed. Rest of the parts are exactly similar to what we talked about: user message template, retrieving relevant documents. And if I go and ask this question, what are the requirements for the indemnity clause to be applicable in case of a copyright claim? We are testing the retriever, and the retriever has indeed retrieved the top 5 relevant chunks. You can see the top 5 chunks are retrieved fine by the retriever, and we can see that we can test it out. This is a good first round of testing we can do. And once this is okay, now we can compose the entire prompt. Okay, so this is the user input. Here we have concatenated the user input with the retrieved context. This becomes the complete user message. Mind you, the entire user message is a concatenation of the retrieved context, the 5 chunks, plus the original user question, which is this one. What are the requirements, right? So this is the whole user message. We have the detailed system message that we wrote above. And now we are back to the chat completions create. This is the standard way how we are doing it. Okay, and because this is a factual application, I'm setting temperature equal to 0 because there should be no variability, right? It's a factual use case. So if I ask you what is the pricing of a GPT 3.5 turbo model, it is not, the answer cannot be variable. It's a very fixed cost. See, today if I ask you what is the pricing of ChatGPT Plus, ChatGPT is $20 per user per month. There are no two ways around it. If I ask that question, it is not that someday you will say $20, another day you will say $21. That we cannot afford. It is one and only one answer. We cannot have two different kind of answers there, right? So that's an important thing to keep in mind, that if you are asked this kind of a question, you will have to be very clear about the about the kind of responses you're getting, and the responses will not be variable. You will typically keep a higher temperature value for more open-ended generation use cases. But this is very specific factual question. So we'll typically keep a temperature value equal to 0. And it's also very common to use a try-catch block, try except exception block in Python, because if some users enter some wrong things, then we don't want the application to error out. We will do exception handling, and most likely some kind. This could be some content filtering error. We were seeing this yesterday also, right? Remember there was a content filtering error. So if a user enters some kind of explicit question, okay, some abusive things the user is asking, which is not relevant to anything in OpenAI, right? So they're asking some nonsense. People keep some random stuff they are talking about. So some abusive words they are using. So then the content filtering policy will be triggered. Okay. So in that case, the application will not error out. Only thing is that when a user asks that kind of a question, the application will say that, sorry, I encountered the following error. So that is basically a kind of a error handling that we have done here. And you can try it out. You can try it out real time in whatever code that you've written. You can try some random nonsensical text. Okay. And you will see the kind of responses you're getting. Okay. So this is a very basic use case that I wanted to show you. I've also uploaded the solution file for the other case study. Very, very interesting one. This is the Government of India case study. And this is also a very real world application. And as I told you, like whatever we discuss with respect to OpenAI and Tesla, the same can be extended to any kind of document, any kind of files. And it doesn't have to be PDF files. It can be any kind of text. Okay, the file can be present anywhere. It can be a database anywhere for that matter. Okay, so we have a Ministry of Finance report right now. This is the thing that we have again. And what we want to do is we want to build a RAG system on top of it. So I already gave you a question notebook, and this is the solution notebook which I have uploaded for your reference. You can go over it, but the approach will be very, very similar. Just that this notebook is a little bit more methodical. It's a little bit more methodical where we go over all the pieces. And what is the objective here? You're tasked with providing key highlights and details for specific questions from this report for your organization. This could be very helpful for government ministries and let's say things like the Planning Commission or the Niti Aayog, as we call it now, right? So these kinds of institutions are basically involved in budget planning, uh, the country's economic development. What is the roadmap ahead? Or let's say some kind of RBI policies. The RBI has to decide a monetary policy. Should they reduce repo rates and all that? So a lot of those kinds of high-level macroeconomic decisions will depend on the government's finances. So the annual report is actually very, very important. Okay, so these are all very real applications we are talking about. Okay, how helpful these kinds of systems can be. You can see the approach is very similar. Again, we load the PDF file. We are using PyPDF loader. The solution is given to you. You can just straight away run it from here. So we are creating 799 chunks. The number of chunks is again very relative. Okay, so you have to again test it out. There are different chunkers are there. So don't try to have too many chunks and don't try to have too less chunks. So the number of chunks is again something you need to keep optimum and you need to play with it. Okay, if there are too many chunks, the retrieval will be a problem. If there are too few chunks, then doing the chunking itself is useless. Okay, so imagine what is the best case scenario? The best case scenario is we don't do any chunking. The whole document is one chunk. That's the best case scenario, right? So here we have a 400-page PDF file. So we say that entire 400-page PDF file is one chunk. Now, if I do that, then there is no need for a RAG solution itself, right? Think about it. If I say that the entire document is one chunk, then there is no need for a RAG solution because every time you ask a question, that only one chunk will be retrieved. And now it is up to the GPT model. We are putting the entire focus on the GPT model to generate the answer out of whatever chunk I've given it. And what is the other risk of having a single chunk? The other risk is that you end up sending the entire data as a context. That is the other risk. So doing the all this RAG approach itself is useless if you have a single chunk. So idea is to have many chunks. But the other extreme is if you have too many chunks, then also it's a problem. Why is it a problem to have too many chunks? Because imagine, if I say I have a million chunks, if I have too many chunks, then each of those chunks become very fragmented. There is very little information that is present in each and every chunk. That is the other extreme that is possible, right? So one extreme is that we have a single chunk that is anyways useless because the idea of RAGs is to create chunks, right? The other extreme is, imagine, I'm just taking a random case. Other extreme is every character is one chunk. Can you imagine? Every character is one chunk. Maybe to help you visualize this a little better, I can show you a beautiful example to help you visualize this a little better. So let me share a beautiful example with all of you. So this is a visualizer for the chunk, okay? How the chunking happens. And you can see this one. This is a sample text I have. If I say the chunk size is equal to 512, this is the general one, right? So I'm just keeping a general chunk size. Let's say if I say 64 or if I say 128, this is the general chunk size, okay? It's a general chunk size I'm setting right now. And you can see, I think the chunking has happened decently, right? Every two paragraphs, we are getting a chunk. Can you see? The moment I say 680, you can see every two paragraphs is one chunk. This is chunk one in blue, chunk two in yellow, chunk three in orange, chunk four in this. And you can see how we have done the chunking right now. Now, the problem is if I say chunk size one, this is useless, right? See how many chunks I'm creating. This is what I said is a problem. So this is something we should never have. We should not have like every character is one chunk. Because imagine if you're saving this in a vector DB, how funny the vector DB will look like. So you will have a character called O, okay, or you'll have a character called, N, E, and you will create embeddings for that. This is useless, right? So the number of chunks should be optimum. And that again has to be tried and tested. There is no one way to answer this question. It has to be tried and tested. There are different ways you can do chunking. And there is even something called semantic chunking. The one that we are doing here is like a fixed size chunking. You're chunking based on 512 characters. If you see the code, that's what we have done, right? Mostly that's what we have done. We used a fixed size chunking. Can you see chunk size equal to 512? This is exactly what we did here. We are saying, okay, every 512 characters, you create a chunk. So every 512 characters, you create a chunk. So from here to here, there are total 512 characters. Okay, so every 512 characters, we are creating a chunk. But we can change that. And there are different ways we can do chunking. Chunking can also be done based on other approaches. So chunking can also be done based on semantic techniques. We can also do something called semantic chunking. You know what is semantic chunking? So very briefly, I'll I'll show you. Semantic chunking basically means that you chunk based on the semantic meaning of the articles. This is the general idea. So what we did was we did fixed length chunking, fixed size chunking on the right hand side. So every 512 characters we have a chunk with some overlap. On the left hand side, what you do is you do something called semantic chunking or theme based chunking. That means you have the entire document, and based on some Gen AI model, we are able to figure out what the different parts of the document are. So let's say if we have the Government of India annual finance report, that particular document will have different sections, right? So now based on different sections, the chunking will be done. So the introduction part will be chunk 1, section 1 will be chunk 2, and conclusions will be chunk 3. So this can be in completely different page numbers. This can be completely discontinued, like the order of the words may not be, the order of the sentences may not be sequential. Let's say some part is taken from page 1, some part is taken from page 3. That can happen. Or let's say from the Ministry of Finance report, I create theme-based chunking. That is, there is one theme about GDP, there is another theme about finance, another theme about defense, because the government will highlight their expenditures across different categories, right? So I will create theme-based chunking based on different categories. So there are many, many different types of chunking strategies that you can explore. Just wanted to highlight that part. Anyways, so now you can create the vector DB. This part is the standard. We take an embedding model and we create the vector DB. The vector DB usually takes a little bit of time to create. And I also told you how to speed up the process. Go to runtime, change runtime type and user GPU. Okay, so GPUs will be usually needed for the vector DB creation because we are using an embedding model and we are trying to take every single a chunk, and we are trying to use an embedding model to convert them into their embeddings. This part is actually very, very compute intensive. The part where we are using the embedding model and we are trying to convert the chunks into their respective embeddings. And that is why the GPU part will be needed. Rest of the parts are very simple. This is the system message specifically for the GOI use case. User message template will be exactly the same as we did before. And top 5 chunks are retrieved. And I think the question we are asking is, what are the trends observed in this investment? Right? So this investment thing, and you can see how the LLM has answered it. Very nicely, the GPT has formatted the answer. So the 5 chunks that are retrieved are very random, but see how the GPT model has generated the answer in a very refined manner. And these are a few other samples I've given you. You can you can run this notebook and then you can try out these samples. This code will run exactly the same way. Okay, so provide an analysis of direct and indirect taxes. You can just run the code. This is what we will actually get. Provide the financials for the agriculture sector. I've already given the user input. What you need to do is you need to concatenate the user input with the retrieved context, add the system message, and just give me the complete response. That's it. Just will hardly take 5 minutes as an exercise, which you can do later on. And the last part is where we did the evaluation of the prompt, the RAG application that we built, and we are using the groundedness judge, and we are using the relevance judge. There are 2 different judges we create, and we can see what kind of ratings the judges are giving.